Hello everyone, in this video we will learn about distance time graph. So you might have seen that newspaper, magazine, etc. different type of informations are provided in the form of graph. For example, if you observe this type of graph, so this is a bar graph. So in this all the information whatever is provided, it is in the form of bars. That is why it is bar graph. We also have a different type of graph. For example, this circular graph is the pie chart, and this pie chart is representing different type of gases component in the atmosphere. And another type of graph that we call the line graph, because only line is represented, that is why it is a line graph. So basically distance time graph is a line graph. So for representing the distance time graph, first of all we have to take a piece of paper, and on this piece of paper we have to make two lines which are perpendicular to each other. For example, we have to take the paper and then we have to mark the line like this. So this portion is the x, this line is the x and the x dash. This is the y and this is the y dash. And the center or the portion where both the lines are intersecting, we mark it as O. So this is the O. Now to plot a graph between distance and time, first of all we have to take the scale. For example, if we are taking this, so just because we are using the distance time graph, so in this was the y and this is y dash and this is x, this is x dash, and we said this is the O. Whenever we are plotting the graph, so the portion between y to O and O to x, so this is the portion where we represent only the positive value. So in this chapter we will use only this portion. So whenever we want to plot a graph, at that time what will happen, first of all we have to mark the scale. That means if we are taking the one block, this small block, or the two or three blocks we are taking, suppose this five blocks we are taking as 1 minute. So we have to mark the scale, or we have to assume the scale that 1 centimeter is equals to 1 minute. Similarly, 1 centimeter cube is equals to 1 kilometer. So that scale we have to mark, then only we can plot a graph. So how we can plot? For example, first of all, we need some readings. So suppose this is a reading. In this time is 1, 2, 3, 4, 5 minutes, and distance is 1 kilometer, 2, 3, 4, 5 kilometers. So how we will plot the graph? Let's see. So suppose I'm taking the scale and I have a blank sheet. In this blank sheet, first of all, I will make the line like this. After that, I will mark. So this will 1, 2, 3, 4, 5. So these are the for the time. So the lower, that is the x and y. So the x and 0. So this will be the time, and y to O, it will be the distance. So for distance also we can count 1, 2, 3, 4, and the last one 5. So how we'll plot? The first of all, in the column that we have the reading that in 1 minute the distance was 1 kilometer. So first of all, 1 minute, so it will be here, and 1 kilometer it will be here. So we have to mark the point at this position. Similarly for the second one, it will go up and second to there. So it will be a this one. Similarly, the other readings was also there. This will be the third one and the fourth one. Now it is not compulsory that always the time and the distance will be the same. That means it will in the 1, 2, 3, 4, 5. Maybe the time and distance will be in other number or in other ratio. So you have to mark accordingly. For example, if we are taking the another graph, for example, we have the distance and time. So if the distance is 2, 1, 4, 2, 6, 3, it will be in minute and it is in kilometers. So what will happen? First of all, this is x portion, this is y portion. Similarly, we have to again mark the points. This is 1, 2, 3, 4, and here also we have to mark 1, 2, 3, then 4, whatever. Now, as we know what we are taking, distance and time. So distance was 2, 4, 6. Here 1, 2, 3. So for time, we are taking the lower portion and distance is the y on 0 portion. So how can we match it? So for time, it is 1. So here is the 1 and distance is 2 kilometers. So 2 is here. So what will happen? We have to mark here. This is the first point. Then for second point, time is 2 minutes. So this is 2 minutes and the distance is 2 kilometers. So we will mark here. So whenever we are having the graph like this, so suppose your readings are always match. Whenever you are crossing this, so you are getting a straight line. So this type of motion is a uniform motion. For example, if your graph is plotting, whenever you are plotting the graph, at that time you are getting the graph like a straight line. This there. So whatever the readings are there, it is always present on the this portion. So if this occur at that time, we can say it is a straight line. And if the straight line occur in a graph, then we can say it is a uniform motion. But if the graph is not uniform, for example, if the graph is like this, so it is not a uniform, that means it is not a straight line. And whenever the line is not straight in the graph, that means we can say it is a non-uniform motion. So in this graph, we can easily understand the distance is here, this is the distance, and this is the time. So at 1, we are marking at the 1 kilometer like this. In 2, we are marking here the 2 centimeter, then the 3, then the 4, and the 5. So when we are combining or when we join these points, we will getting the straight line. So if we are getting the straight line, that means it is a uniform motion. Now suppose you have to find the speed of any object by using this graph. So we know that speed equals to distance upon time. So we have both distance and time. So if we calculate the speed of an object at this portion, so what will be the speed of that portion, or we can say at 3 minutes, what will be the speed of an object? So at that time, what will happen? We have to say that speed equals to what is the distance? It is 3 kilometer. And what is the time? It is 3 minutes. So it will be 1 kilometer per minute. Similarly, for the first one, so 1 by 1 equals to 1 kilometer per minute. So if the graph is uniform, in that condition, you can find only the single, you have to calculate the speed at single time. And whatever the time speed you are getting, it will for the all the readings. If the graph is straight line. So whenever the graph is in a straight line, at that time you have to calculate the speed at once and it will for the each time.